In this video, we're going to be given a linear equation in point-slope form, and we want to rewrite that equation in slope-intercept form. And we're going to see how to do this in the following example. So let's say we have the equation y plus 1 equals 5 times x minus 3. Okay, we can clearly see that this is in point-slope form. We have y that's not solved for, and we have x on the other side in some parentheses. So this is definitely point-slope form. We want to convert this into a slope-intercept form, and we simply do that by solving for y. Slope-intercept form is y equals, and then our slope times x, and plus our y-intercept. So we'll see why that's useful in a second. So let's go ahead and distribute this 5 into the parentheses. Again, we're solving for x. Oh, excuse me, we're solving for y. We're going to y by itself and everything else on the other side. So we have 5x. 5 times a minus 3 is minus 15, and we can write this step in. We can subtract 1 from both sides, which will cancel those two terms, so we have y equals 5x minus 16. Okay, this is the same thing as this equation, but in slope-intercept form. Now, the reason why slope-intercept form is so useful is that we can quickly pick off the slope and the y-intercept, which are very two useful pieces of information. The slope isn't really singled out here if you don't know what you're looking for, and especially the y-intercept would take a little work to find it. So, but right here, it's easy to look off, well, there's the slope and there's the y-intercept. So having the equation in slope-intercept form is very useful, so we're going to practice converting point-slope form into slope-intercept form by doing a few more examples. So let's see, we have y minus 3 equals 1/2 times x minus 2. And that's our equation in point-slope form. We want to convert it into slope-intercept form. So let's go ahead and distribute this 1/2 into the parentheses. So we have y minus 3 equals 1/2 times x minus 1/2 times minus 2 is minus 2 over 2, or just minus 1. Okay, now we can add 3 to both sides, which will give us y by itself on the left. We'll have 1/2 x minus 1 plus 3 is plus 2, and that's our answer. Okay, and we can quickly identify the slope here and the y-intercept here. Very useful, especially when we're trying to graph a particular linear equation. So let's look at the next one. Let's say we have y plus 8 equals a minus 4 times x plus 7 over 3. 7 over 3. Okay, we have a fraction here, but that's nothing to get excited about. We know how to deal with that. Let's go ahead and use what we know and solve for y. So we have y plus 8 on the left side. Let's go ahead and distribute this minus 4 into the parentheses. So we have a minus 4x. Again, we're distributing a minus sign, so we need to be careful that our signs change. Minus 4 times 7 is a minus 28 over 3. We can subtract both sides by 8. So y equals minus 4x minus 28 over 3. Let's go ahead and convert 8 into a rational number that has the denominator of 3. So it's going to have a minus, and it's going to be minus 24 over 3. 24 over 3 is the equivalent of 8. And now we can simply subtract these. So one more step, we have y equals minus 4x. Now instead of subtracting, we can add a negative. So we have a minus 52 over 3. And that's our answer in slope-intercept form. Next one we have is y minus 0.75 equals 5 over 4 times x plus 1. Okay, here we have a decimal and a fraction. So I like to convert one to the other before we even get started. And you know me, I'm actually more familiar, more comfortable dealing with fractions than I do with decimals, because I tend to lose decimals. So just like negative signs. So let's go ahead and add in a step here and convert this into a fraction. So we have y minus 0.75 is the same as 3 over 4. And rewrite the right-hand side. We have 5 over 4 times x plus 1. Okay, now we can go ahead and distribute this 5 over 4 into the parentheses. So rewrite the left-hand side, y minus 3 over 4 equals, we have 5/4 x plus 5 over 4. Okay, now last step, we simply move the minus 3 over 4 to the other side. It becomes positive, so we have y equals 5 over 4 x. We have a plus 5 over 4, and we're adding 3 over 4 to it. And we simply combine these terms. We have y equals 5 over 4 x plus 5 plus 3 is 8. 8 over 4 is simply 2. So here we can quickly identify our slope as 5 over 4 and our y-intercept as plus 2. Okay, so having our equation in slope-intercept form is extremely useful. Let's do a couple more of these examples in converting from point-slope form. We have the point-slope form here of y minus 5 equals 6x. Okay, here we actually have a 0 as the x naught value, so we know the line, the point on a line is 0 for x. So all we simply do is just move the 5 over by adding 5 to both sides, so we have y equals 6x plus 5. Note this is still a point-slope form right here. We actually saw it in the previous section. And here's the slope-intercept form. It was actually pretty simple to convert that. Let's go ahead and look at one more. Let's say we have y plus 6 equals minus 1/2 times x minus 4. Minus 4. Okay. So we simply just distribute this minus 1/2 into the parentheses, leaving us y plus 6 on the left-hand side. We have a minus 1/2 x on the right-hand side. Negative and a negative gives us a positive. 1/2 times 4 is 4/2, or just 2. And we finish off by subtracting 6 from both sides, which will leave y by itself. That's what we don't want to do. We want to solve for y. That puts it in slope-intercept form. 2 minus 6 is a minus 4. And there we go. So the slope-intercept form of the linear equation is such, and the slope is right here, y-intercept is right here. Very useful to have slope-intercept form with our y being solved for, so we can pick out useful pieces of information. And we just want to get some practice in converting. If we're given something in point-slope form, we want to convert it into slope-intercept form. It's a little easier to deal with sometimes. And in the next video, we'll actually be graphing point-slope form equations. So I'll see you soon.